Kung Fu, you know what it is. It's awesome and it makes for great classic movies. You probably even watch a movie about a panda that becomes a master at it. Well, in this video, I'll show the progress of an AI that learns Kung Fu from playing the 34-year-old video game Kung Fu Master on the Atari 2600 console. And that is simply by looking at the pixels from images of the game, same as a human would do. Alright, now let me introduce you to this AI. Its name is Fives. Here's how well Fives plays the game without any experience. Pretty basic, completed random actions or no actions at all in this case, as any apprentice would do, I guess. Okay, so how do we go from an AI that does random moves to an AI that actually plays the game at a human level? I'm going to keep the explanations very simple, but if you're not interested in understanding what's going on and just want to see an AI throw some kicks, then you should skip to this part of the video. Alright, so there are a couple solutions to reach our goal of having an AI perform well in the game. First, you can tell the AI exactly what to do at every step in the game. Now that might sound simple, but remember that Fives is learning from looking at pixels of the game without any prior knowledge of anything. For all it knows, it's trying to control this background pixel to reach this region. So imagine yourself actually writing down every rule the AI should follow. For example, if this pixel is this color, then do a kick. It will take you a very long time, and whatever rules you decide on might only be good for the beginning of the game, because the rules may change if the game gets faster and more difficult towards the end. Okay, so let's forget about our first solution, it's unfeasible. A second and better solution is to use deep reinforcement learning. Why? Well, because instead of writing down all the rules, you let the AI figure out what the rules are. It's kind of the equivalent of being a terrible parent that doesn't set any rules and doesn't supervise their child AI. For example, oh what, Timmy's about to put his hand on a hot stove. Oh, just let him, he'll learn. Oh what, Timmy's about to cross a highway. Oh, just let him, he'll learn. Of course, people won't make a big deal about treating an AI like that because an AI isn't alive, right? Okay, so you let the AI gain experience from playing the game a lot, and he'll figure out what the rules are on his own by trial and error in an unsupervised manner. Alright, now one last detail. There are multiple methods in reinforcement learning. You might have heard about Q-learning. Today I'll be using something different called Proximal Policy Optimization, or PPO. I know those words might sound scary, but don't worry. There's only one thing you need to know about PPO, and that's that baby steps are very important. For example, let's say that the AI does something amazing, like he stopped buying plastic water bottles, or took his bike to work, or baked muffins for everyone. Then you don't want to give him bigger rewards so he keeps doing those good actions, but there's a catch. If you give him too big a reward, he might take that good action to the extreme. The AI will try to bring a truckload of muffins every day as to receive even more rewards. And is that really what you want? So you should keep the rewards small and slowly change the behavior of the AI. Learning one baby step at a time will make sure the AI doesn't go crazy all of a sudden. Alright, enough of the explanations, now comes the important part, the training. Fives will have to learn many things. First, the purple shirt guys are huggers. If they grab onto Fives, he'll be stuck and slowly lose his health until he frees himself from their grip by alternating between pressing left and right multiple times. Second, the great potato throwing ninjas. Yeah, they will keep their distance and throw stuff, and Fives will have to either duck under the projectiles or jump over them to avoid taking damage. Alright, so this training will take many hours because we're essentially training a miniature brain with a couple 100,000 connections. It's a neural network, this is what it kind of looks like. But don't worry, I'm just going to be showing you the highlights of the training so you won't have to go through hours of footage like I did. Right, so as an indicator of how much training the AI has had so far, number of games or episodes of training is in the top left corner. So after playing only 50 games for about 10 minutes, the AI is already doing far better than it was when it started off. So there's this thing I didn't know about, but that Fives is actually learning right now, is that if he looks away from the gray ninjas, they'll stop throwing their stars and actually try to grab onto him. And he can attract them very close, and just as soon as they're ready to grab him, he can turn around and punch him or kick him and actually get more points that way. So another thing I want to mention is that it's actually very difficult for Fives to learn how to get out of grab, because not only does he have to do the whole sequence of pressing left and right multiple times, but also he doesn't make any points for getting out and defeating the enemy afterwards. So the only way he's gonna learn that it's beneficial to do that sequence and defeat the enemy while he's grabbed is because he'll be able to later on make more points since he survives longer. After 1 hour and 200 episodes of training, Fives is now backing himself into a corner, pretty much all the time. It's not really a good strategy, but there's a reason why it's happening. You see, there's randomness that's added into Fives to ensure that he explores different ways of playing. Early on in the training, he was going left more often, and he remembers how many points he was making going left. Now he's trying out to see if when he goes right if he makes any more points. Alright, so we're a bit further in the training, and I wouldn't say the AI got better, but its behavior definitely has changed. Now it's crouching all the time like it's taunting its enemies. It's also looking back and forth like it's doing some sort of spinning animation between punches. I really don't know what's up with that. Okay, so at this point I think there are two things I need to highlight. Yes, the AI can jump over projectiles, but second, what is that? Okay, so up till now I haven't talked about the score in the game and what it represents when trying to compare the performance of the AI to that of a human player. This is where I need your help because I have very limited data on what the average score for a human is. I've had some people try the game, but they would only score a couple thousand. And that's pretty low compared to the 20 to 30,000 some research papers on topic of AI in target games were considering. I've also watched some YouTube videos of people that are very good at the game get way more than 30,000, so I really don't know what number to consider here. But if you look in the top right corner of this video, I set up a poll that you can answer with your own average score if you decide to play the game in the near future. But back to Fives. He reached his highest average score at 700 episodes, which is about 4 hours of training. I'll end this video with a clip of Fives getting his highest score, but just before that I want to show what happens if we let Fives train some more. At 1500 episodes of training, Fives can do this, which is pretty cool. And at 2800 episodes of training, Fives finally stopped kicking and punching the air. Well, almost. Who knew it would take 13 hours to learn that? Anyway, thank you to anyone still watching. Please share this video if you enjoyed it. Here's Fives getting his highest score.